everyone was looking for more BIPV. I just have introduced it to the last to create interest in this session. BIPV, the most important part of the BIPV is that the cells should integrate with the building design shape. Basically, it must be like a seamless structure, a seamless integration of the modules with the structure. The orientation, also we need to understand where to put the BIPV so that we get maximum power out of it. And of course we have to manage the thermal part, because these cells will get heat up and then they will radiate heat inside the structure also. So there should be a proper management so that the heat is dissipated out, and whatever we can extract out of that heat, we can generate electricity. Having a better management of this thermal part will be ensuring that my cells last longer. And of course it should be integrated in such a way that if I tomorrow if I want to increase the number of cells, or maybe I can if I want to increase the floor also, it should not hamper any flexibility. The other part is BIPV can be integrated into multiple architectural structures. I mean, multiple architecture elements, not only for the roof. It can be used into cladding. So basically, your wall cladding can be also with BIPV. Windows or curtain wall application that we have already seen. Even on the roof, it can be used as a skylight. We can use that as an application. And of course I'll show you a couple of examples where even the shading devices have been designed with respect to BIPVs. uh, BIPVs do come at the different colors, but I would suggest that not use those colorful BIPVs, because of the simple reason that efficiency will decrease. A few of the examples as to how these solars are implemented in India. I'm not showing any images out of India. I'm just trying to emphasize that the solar is widely used in India, and just that uh, the application or the design needs to be incorporated in such a way that we can facilitate more and more renewables into this. So the biggest the solar that is being BIPV that is being used is Controller's data center, which is in Mumbai. So almost about 2,466 cells are being used on the facade, which is almost about 51,000 square feet of the facade area is covered with this, and a total capacity of almost 863 kilowatt is being generated. Of course, being a data center, the requirement is much higher, but then having this much amount of capacity is quite astonishing with respect to BIPV. Till date in India, it is one of the biggest installations. So as I just discussed a few minutes before, uh, this particular showroom has used BIPV as a shading device. So just as the entry, you can see a large canopy where about almost 7.2 kilowatt of solar is installed and the energy is generated. One more example as to how buildings can be designed. Now, this is not exactly a BIPV, but the roof is designed in such a way that I get my north light at an atrium, which is required. So I have my skylight for the atrium part, as well as it is generating energy also through this sawtooth type of structure, wherein on the south facade the panels are being installed, and at the northern side I have glass from where the light is coming through. So due to the limitation of space, the project has designed this thing wherein solar as well as light both is being obtained. One more example of innovative design, I would say, at a school which is in Thar desert of Rajasthan. Here, the solar panels, I mean, the elliptical shape is also designed in such a way that most of the open areas are in shade, which being a school is quite necessary for children to have recreational activities. Even on the roof, the solar is installed only a part area where the sun and the angles are favorable for maximum generation, and it has been the design is done in such a way that the that this panels are creating shade for the area space below, which is a ramp, wherein it's often like children would play at those areas. And even at the surroundings, you can see that there is jali which is being designed with respect to many geometrical patterns. So with respect to learning and playing, the solar energy is also generated. I believe no solar or renewable discussion would be complete without mentioning this one of the most decorated building, Indira Paryavaran Bhavan. So this being a government building, it has many accolades. It's basically IGBC platinum rated building and even net zero building. Here also the PIPVs are being used for roof as well as for shading. You can see a lot of projection that has come out from the top floor, which is providing shade to the building as well as cutting the sun angles also. Sorry. The total capacity of the solar that is installed is about 930 kilowatts, and if you just calculate the EPI, this is actual EPI and not calculated or simulated EPI. It's about 24 units per square meter per annum. So this is as low as and it is not a non-conditioned building. There is air conditioning more than 50% of the area. So it is not like government building hai to air condition nahi hoga and the CPI is quite natural. No, it's not like that. The building design is really good, wherein this EPI is possible. One more project which has done slight innovation is installing solar collectors, and the amount of energy that is being generated is sufficient enough to provide solar air conditioning. Here also the specific consumption is about 90, or the EPI is about 90 units. So this project is in Chennai. Even small residences can also integrate. That's not only the corporates or the commercial buildings have been using renewables. Uh, this is a residential building in Kerala where the solar is being used to cover the courtyard, and the courtyard has now become a good resting or seating area where you can do chit chatting. And total of 18 kilowatts of solar is installed on the sky on this courtyard part. Moving on to the second important part, I am not covering everything with respect to the renewables. I'm just covering the solar as well as the wind part, because those are more prominent in India. And I just put more efforts on solar because it is most widely used. Even in the wind, as you can see the picture, it is not amalgamation of two different pictures. It is a single picture wherein you can see that windmills are installed near paddy farms. The total generation has significantly increased, and even though there is limitation that the available wind speeds are there only in 10 states and 2 union territories, we are still able to put almost 46 gigahertz of windmills, which are able to generate energy. So wind power is mainly into western or southern areas, Tamil Nadu being the largest producer of electricity through wind. You can see this graph or the image where you can see most of the wind or the wind speeds available are in this three regions only, the southern being more prominent as well as the western parts of Gujarat. So there, the minimum wind speed through which the energy starts generating is about 4.5 or 5 meters per second, and these are the areas where I can put wind farms wherein the energy is wind speed is in excess of 6 meters per second. Different types of wind farms or wind parks. So onshore, it's basically the turbines that you install on the land. Offshore is the turbines that you put it at the sea. There are also other types of wind turbines, which I'll just deal in next couple of slides. Initially, the growth of wind was very high because there were a lot of innovations, incentives, and government policies which were pushing the growth for this wind power. But now gradually government has taken off those incentives and subsidies, due to which the production has slightly decreased over the last couple of years. However, it's still being in the new policies are being developed, and hopefully this again will get picked up soon. Advantages are standard, basically generation without any depletion of resource, clean energy, and low cost. Upfront is very high, but the maintenance is practically lesser as compared to solar. So the cheap, the production, I mean, after the energy that is produced is very cheap. However, there are a lot of disadvantages, because the energy is generated if you have a stable wind flow. If the wind speed is erratic or intermittent, the energy generation is also not very standard or stable. So of course it is slightly a disadvantage as far as energy generation is concerned. Of course, having wind parks will require a lot of land area, and putting those or encroaching the rural or the forest areas again will lead to industrialization at that area and disturb the wildlife as well. So there are practical limitations as to how we can use that. Nonetheless, there have been some breakthrough innovations wherein small turbines have now been developed, and uh, this can be installed in the buildings and integrated in the building design itself to generate energy. Um, you get these wind turbines as small as about zero point 0.8 or 800 watts. Uh, and the starting speed is about 2 minutes per second, 2 meters per second. If there is a wind speed of that, the electricity starts generating. If there is a stable wind speed of about 5.5 meters per second, you get about 5 units per day. So and also the smaller windmills won't produce that much amount of noise or vibration, so it can be easily installed in your buildings as well, and it can be integrated with solar as well. So different types of smaller wind turbines, you have horizontal axis and even vertical axis. So either of those can be installed over the buildings. Sorry. Installing wind turbines into the tall buildings. So this is one of the iconic building of Bahrain Twin Tower, wherein this wind turbines have been installed. So mostly to install these types of wind turbines, the most important part is to do a wind assessment. That can be done by field measurements or even through computational fluid dynamics modeling, and to understand how the wind would flow at a certain height, or even how we can install, at which orientation you can install the windmill. So by doing this analysis, and by having and by incorporating this wind turbines into the building design, you can take an advantage of the renewable generation. Even at the parapets, a lot of small wind turbines are installed at many places, because the wind speed at those heights are much higher, and they would easily generate energy. The major issue with respect to this is the noise and the vibration. So those studies are very important and critical for incorporating the building design. So as you can see, a more close-up photo of this Bahrain Twin Tower, wherein three turbines of 225 kilowatts are being installed over the bridges. One more example is the China's Pearl River Tower, where this type of design has been incorporated, wherein the funnel effect would create the wind energy, and I mean the energy from the wind surface source. Back in India, if we take the project of Suzlon, they have installed about 18 numbers of smaller windmills, each of wind turbines, each of about 4.5 kilowatt, and they generate together with solar. The total generation is about 2 lakh 30 units per annum. So the turbines are, though not widely used in India, but there are a few smaller ones which are installed in few of the projects here and there. To conclude, I would say there is immense potential of the renewables that we need to explore, and it can be an answer for our increasing demand of electricity. However, implementation, especially of the wind turbine, should be done after careful study. Even for solar, you should study the shadow analysis so that whatever installations you are doing, you get maximum out of it. Integrating will building design will not only enhance the aesthetics but also the performance. Of course, in the result, you may get you may design an iconic building which becomes a benchmark. Policies and incentives are something which definitely IGBC and other organizations are and would be working also with respect to few governments wherein the policies are not so suitable to incorporate more of these renewables. So at the end, regardless of any current financial conditions, all buildings, if they are being designed, new buildings which are being designed should be able to accommodate future renewable energy, and of course using renewables makes economic sense. So thanks a lot very much. I believe I am on time. I would happy to take questions.
Thank you, Jayesh. My question is, how small wind turbines can be accommodated in India, especially uh, small houses, 2, 3 story buildings, which we see in the north? How,
So, as I have shown, you get smaller wind turbines of 1 kilowatt, zero point 0.8 kilowatt, 1.5 kilowatt. So, you get in these ranges, and like the wind turbines that have been installed in Suzlon, it's about 4.5 kilowatt. But for the smaller houses of 2 to 3 storage, I feel you can install wind turbines of 1.5 to 2 kilowatts, which are available. Of course, depending on how the building structure is and the vibrations that it can withhold.
and if you can tell me what is the average price of these turbines available in India?
I'm afraid I won't be able to tell that because that you would be getting it from the vendors only. Maybe in the next session, Naveen can put a light on it. I'm basically a designer or an engineer which would try to analyze the impact of this renewables, but won't be able to discuss about the costing or the installations part.
So, apart from Suzlon, is there any other company dealing in the wind energy, especially for a smaller windmills?
Uh, there are a couple of those, but they are not widely in India. But they do provide the windmills or the wind turbines in India as well. So there is one company which is called as Alcazar. Uh, that is a European company. So that's what I know of. These they provide smaller wind turbines, basically that which can be used.
Say again, can you spell it?
I'll put it down in the chat box. You can get the link from there, and you can surf it for yourself.
Fine,
Yeah.
fine. Thank you.
Mr. Jayesh, there is one more question from the participants.
Yeah.
So, any research on hybrid solar panel to generate power and hot water simultaneously?
Not that I know of.
Okay.
There is something
Can I
which is,
answer this? Can I
yeah,
answer this?
please go on.
So, when we use heat pump for generating hot water, it is very highly efficient. So heat pump is using a compressor or heat in or
Yeah,
yes.
so
So
just to add on it, heat pump would give you hot water as well as cooling impact, but it's not a renewable source of energy as what the question was, I believe, if I get it correct.
no, what I'm trying to say is like you generate power using photovoltaic and then use electricity, especially this efficient method of heat pump to uh, heat the water. This is my suggestion.
True, yeah. So of course, with renewables, you can like one of the project in Chennai that has incorporated solar collectors to power the air conditioning as well. So yeah, having a renewable source, you can use any appliances to do that. Yeah. Anything else?
There was a one question by Sashidhar Dhareshwar. Should we not promote non-air conditioned areas oblique buildings with passive design rather than air conditioning?
Definitely,
Request
yes.
Jayesh.
Definitely, yes. One should promote non-air conditioned building. Of course, it should not be at an expense of thermal comfort for the occupants below. But I definitely agree to that thought.
And I want to add that more than residential building, commercial building consume more energy, and commercial buildings needs to have air conditioning for equipment. They needs to have other energy guzzlers like machines and other things. So just by designing passive designs, air conditioning we cannot bypass. It is not only a comfortable requirement, but it is a machines requirement, automation requirement, so many things. But definitely certain areas where it is only a residential building, if a customer is happy with the comfort level, we can definitely design non-air conditioned buildings as well.
True.
So I think we'll move ahead. Thank you, Mr. Jayesh. Thank you for that wonderful session.
Thanks a lot.
I hope all our participants gained an immense knowledge from the session you just delivered.
Thanks.
So on this note, I would just introduce our next speaker for the day, Mr. Naveen Jain. He is a counselor at CII IGBC who completed his bachelor's from MNIT Jaipur in 2011 with more than 10 years of experience in solar PV and plants. So currently he is a member of our net zero team at IGBC, so who assesses and audits the net zero projects across the country. And he is also a part of net zero training team at IGBC. So I would request Naveen if you can take over the session.
Thank you so much, Sri, and thank you everyone for attending this webinar on renewable energy in buildings. So, as Jayesh told more about the renewable energy, what are the options available, how it is used right now in the buildings to meet their different green buildings and net zero goals. So, further taking this conversation or discussion for how we can basically achieve net zero through renewable energy, and what is the right now framework available in IGBC to assess the project for net zero. So first I'll give more brief about the renewable energy, and after that I'll take up the net zero portion also, how the net zero rating system works in IGBC and what are the things right now we are looking. And if you feel anything which is basically more technical, so bear with it right now, and later if you find any question we can basically discuss on that, not an issue. So as you can see, this is the picture of our center at Hyderabad GBC, and we started with this building as a green building, India's first platinum rated green building, and later we converted this into the India's first net zero energy IGBC rated one net zero energy platinum rated building. And you see the transition which we had taken for making this building to net zero energy, and whole roof area is covered with the solar. And this is not a ordinary solar, it's a bifacial solar, because we have a higher requirement than the roof area available. So we have to go with this type of technology where we can install more capacity of the solar plant which can meet our requirement. So first I'll brief about how we have come up with this net zero concept. As I told, we started with the green building movement in India. Then later on, we thought it's right time to switch to net zero, because the green building movement has taken up by various stakeholders very well, and they want to do more towards sustainability, environment. So we come up with this net zero mission in 2021, making India one of the foremost countries in transforming to net zero by 2050. Why we are talking about the building sector to be net zero by 2050? Because India by nation has come a very ambitious target to become a net zero by 2070. It was declared in COP26 that India will become net zero country in operations by 2070. So why this is most important for the building sector? Because maximum 40% of the energy consumption is in the building sector, 30 to 40% is GHG emissions coming from the building sector. So if building sector is addressed, then addressing other area will be easy, and that can be very easy to achieve. That can be basically help to achieve the net zero targets by 2070. So what we did, we basically break this concept in 4 parts: energy, water, waste, and carbon. And at the time of launch of this mission, 350 plus organizations have committed to achieve net zero status for their new and existing buildings. So as I told, there are 4 rating system available: energy, water, waste to landfill, and carbon. So why I am presenting this? Because see, achieving net zero carbon without having renewable energy is impossible, because no other right now technology for carbon sequestration is available in India, which can help you to offset your carbon emission. So that's why this is a linked concept. Whenever you study renewable energy in the building sector, so that will also guide you to become, how can you become net zero for a building? As I told, it's not only about energy, it's all about carbon also. If you see, achieving net zero carbon is not a standalone thing. It is linked with energy, water, waste. And right now, as I told, only the renewable energy source is the one by which we can offset the carbon emissions. That's why renewable energy is most important aspect in net zero or green buildings when you want to achieve a specific rating under net zero or the green building. And our mission is also aligned with the World Green Building Council. They also talked about net zero carbon in operational and embodied. They also talk about operational carbon and embodied carbon, and how can they offset through the renewable energy. That is basically discussed in this framework. So we launched this rating system in 2018, which talks about first reduce your consumption, first implement energy efficiency in a building or project, and later whatever the energy consumption is there, meet through the renewable energy. This is the, I can say, broadly concept of the net zero in the IGBC. And if you see, there are several methods for approaching the net zero for a project. Active measures, passive measures. Passive basically talks about more when the building in design, orientation, envelope, and active basically after the installation, when the equipments are there, how they are using energy, how can we bring energy efficiencies in those equipments. We talk more about in active measures. And later, whatever is there, after having all the energy efficiency measures implemented in your project, the renewable energy can offset your the energy consumption, and that can be done through on-site and off-site. Now, up till this, I talked about the net zero as a concept, how this renewable energy is linked with the net zero concept, and now I'll talk more on about renewable energy. As Jayesh also discussed about the renewable energy, I'll just go through this major broad concept. What is the renewable energy? It is nothing but that can be replenished on a human time scale. Any energy, any form of energy that is collected from renewable sources and which are naturally and replenished on a human time scale. Solar come from sunlight, wind come from wind, hydro come from rain and water available in rivers. Waste to energy, non-biodegradable waste which is available, we can make use of that waste to make to generate energy. And these are the type of the sources which defined by MNRE as a renewable energy. So bioenergy, again, biodegradable waste can be used for that. New technology, right now, these are the technology which are in research, and somewhere the pilots have been done for hydrogen, ocean, and geothermal. So these all are considered under the renewable energy. But if you see, the major sources are not basically directly one can install on their the rooftop or their project premises. Only solar, wind, that is the two major resources or the type of the renewable energy which we can directly install at our premises, or we can directly have the access through the offsite also. Like hydro, waste to energy, it requires a lot of efforts, a lot of money also to put in, but it requires more than that the feasibility and other aspects also. Like everyone, like if you see your rooftop, you can directly go for the solar. Definitely for wind some study is required, but for the other aspects, other sources of renewable energy, it is not easy. So for this particular discussion for the building sector, we'll discuss more on about this solar and wind. So I am giving right now on a brief how the renewable energy sector basically evolved in India. So if you see, before 2010, there is no much talk about the renewable energy directly, what I can say, install at the rooftop or at a bigger scale. But in 2010, government has come with the NNSM, Jawaharlal Nehru Solar Mission, and which talked about only 20 gigawatt of solar energy in 3 phases. Now I have talked about only 20 megawatt at 20 gigawatt. At that time, it was a huge number because there was no much concept, no much technology, and it was just came up with one mission that we have to do something, and they have put a target of 20 gigawatt by 2022 in 3 phases, like 2010 to 2013, 2013 to 2017, and 2017 to 2022. That was the initial target. But after seeing a lot of technology interventions and the affordability of the renewable energy sources, majorly in the wind and solar, so government has revised their target from 20 megawatt to 20 gigawatt to 100 gigawatt by 2022. A huge jump, and in which 100 gigawatt, 40 gigawatt should come from the rooftop solar, specifically solar, and that is all from rooftop solar because it has a huge potential. A study claimed that more than 600 gigawatt of solar energy can be generated from all the rooftop available in India. So as of December 23, India's installed capacity is 11.08, which is very lower than the target set in 2050, that is 40 gigawatt. That's why government has revised this target, and now the target timeline is the 26 to achieve this 40 gigawatt of the rooftop solar installation. As of March 24, India's capacity is 11.87 gigawatt rooftop solar capacity, and this is basically after having the highest growth in last 1 year. 2.99 gigawatt was added in 2023-24. So after having so highest growth also, we are still quite behind with the targets. Almost 1/4 we have achieved. Now, if you see India's ambitious target to install 500 gigawatt of renewable energy, including all wind, hydro, solar, bio, everything. So if you see in that 500 gigawatt, also 280 gigawatt should come from this solar. That's how important the solar is this, and how I can say we have the potential to generate solar. And one most important thing is 280 gigawatt include both rooftop as well as ground mount projects. So if you see right now, the big 3 states are Gujarat, Maharashtra, and Rajasthan. And if you see, Gujarat is way ahead of all these states. It's have more than 3.4 gigawatt of installed capacity. Second, Maharashtra, it's 2 gigawatt of the capacity. And third, Rajasthan, 1.1. So still lot of work has to be done in this sector, and lot of incentive, lot of push should come from the government so that it can be adopted by many. And right now also you have heard about PM Surya Ghar Yojana, where the government is providing subsidy for rooftop project for the small houses or residential. So that's where basically government is also pushing, because they have set an ambitious target and they want to complete it, and that's why they are pushing through this incentive for the residential owners. Now, what are the renewable energy sources in terms of the how it is installed? So we basically term as on-site and off-site. So on-site renewable energy sources, what type of can it be? One, solar power plant on rooftop, ground mount, parking sheds. We can put solar and we can generate energy based on the analysis. Again, some feasibility study and analysis required. You can't put anywhere the solar panel and expect generation from that, because you have to avoid shadow area. You have to see the direction. You have to see the inclination. After having all this study, wherever you find the feasibility to that the solar can generate energy, you can put, and you will definitely get good energy generation from them, and it has a business sense also. I'll talk later on this on the economics part also, but that is the point important, that it's not that everywhere solar can generate energy. It will generate, but it will not generate at optimal rate, optimal its capacity. So that's why a proper feasibility and analysis is required before putting solar. So as I told, it can be installed on rooftop, ground mount, and parking sheds. And now, what are the types of the on-site solar with respect to the connectivity with the grid? If it is not connected with grid, having only battery backup, it is called off-grid. If it is connected with the grid, it is called grid connected. If it has both grid connectivity along with backup, then it is called the hybrid. It's very easy. Off-grid means not connected with the grid, grid connected with the grid, and hybrid means both grid connection and battery backup based on your requirement. Like if there is no grid available, like any remote area where there is no access of the grid energy, then off-grid solar project is important. That should be put. And it's not like only rooftop. Right now, mini grids also works, where you can put a good capacity of solar on the ground mount with the huge capacity of battery, and that can basically give you power with limited limited amount of energy. Because see, you can't put a huge load on these, because batteries are providing the energy, and that has a limitation to how much energy they can provide. But at least you can have excess of energy, and you can meet your basic requirement with off grid or mini grid. Grid connected is basically for more to reduce your energy electricity bill, and have more excess of renewable energy for your project. And hybrid is where the more frequently the energy cut is there. So that's why you want to run your load without interrupting. So that in those projects you can put the hybrid solar. Now again, solar and wind also be one of the as Jayesh told about, the small wind capacity mills can be put on your rooftop, and that can also support you in your renewable energy consumption. And basically this can also club with the solar. So again, there are some vendors or some supplier who can provide you wind solar hybrid system for your rooftop. So that can also be looked based on the, again, for wind you have to do certain analysis, how much wind capacity should be installed, what is the wind flow is there, because wind can be generated throughout the day, but for solar it can only generate through the daytime. So that's why some analysis should be done for the making your project financial viable. See, these are the for simple calculation. If you see how much of 1 kilowatt solar can generate, right now the technology has advanced a lot. Earlier it was told that 4 units per kilowatt is the maximum generation you can get. Now you can get more than 6 units per kilowatt in the peak time. But yes, for average out the whole year, you can get 4.5 units in a day, and yearly 1440 units per year. But yes, right now good efficient modules are available. If you see, if it is properly installed, if it is having proper grid connectivity throughout the day, then the per kilowatt 6 units can be generated. So this is the new advantage of the having a high efficient solar modules and the bifacial solar modules. So as I told, for a normal house, 6 kilowatt system is enough, and it generally occupies around 10 square meter of built up area, 10 square meter of the area. Now there are certain concepts which you have heard during different conversation. If you deal with this type of rating system, or if you have done any project installation, or if you are involved in any project installation, so there are certain things when you talked about the grid connected system. One is net metering, gross metering, then net billing, and then virtual net metering. So I thought I'll just go through these concepts so that anywhere if you go, you can basically relate this concept with the renewable energy and how it works. So net metering is nothing but when a grid connected system is having 2 meter setup, where the solar energy generated can be first used in the house, and if it is excess, it can supply to the grid in the daytime or whenever it is excess. Because I'm talking about renewable energy, it can be a it can be a solar and wind both. So what is the net metering? first, whatever the energy generation is there, you consume it for your project. Then if it is excess, send it to the grid. And whenever you have the more requirement than the generation, then whatever energy you take from grid, that will be offset or the compensate whatever you have given to the grid. So in the month time, whatever you sent or exported to the grid and whatever you have imported to the grid, the balance will be taken as the consumption, and based on that you will be charged. So for this, 2-meter system is required. One to measure how much solar energy or renewable energy is generated, and out of this, one second meter is for the net meter, to understand how much is exported and how much is imported. So this is the basically a net metering concept. Majorly in the domestic, this net metering is done in major states. Some states have stopped taking this project under net metering because of certain reasons. But I come from Rajasthan, there is net metering going on very good in the residential. Even in the commercial also, net metering is done up to 1 megawatt, but you will not get benefit for the excess exported unit. So to meet this challenge, the government has come up with the second option, that is a gross metering. So what in gross metering means that whatever the solar energy is generated, that has to be calculated separately. That is basically measured separately, and whatever you're taking from the grid, that is measured separately. Now, whatever the total consumed will be taken at a different tariff, and whatever you have supplied, it will be charged at a different tariff. Earlier, whatever you have consumed, that is not ever anywhere taken in consideration, but whatever you given as a exported and whatever you taken as a imported, balance amount should be charged at the retail tariff. But in the gross metering, both the units generated, like both the sources, like renewable energy and the second is the grid, charge at a different tariff. And based on the difference of the amount, you will be billed. So if you are generating 100 units solar and you are consuming 200 units of grid, then 100 will be charged at 3 rupees and 200 will be charged at 8 rupees. Now, difference of both will be basically you have to pay. So this is something I can get discouraging thing, because your solar energy will be charged at a different tariff, at a lower tariff, which is not basically, you are basically installing for making your consumption low, but it will be charged at different rates. So it will not encourage more consumer to adopt this system. But if you see in some state, it is already implemented for commercial, so there is no other option. But residential right now, this is not anywhere I have heard. Now, third is net billing. That is somewhere better than the gross metering. So what is happening? Whatever the solar or the renewable energy you are generating, first you consume it, excess will be going to grid and it will be charged at different tariff. And whatever you are consuming from grid, it will be charged differently. That means whatever you have generated and used yourself, it is nowhere basically calculated under the differential tariff. So somewhere you have benefit, whatever you are using while the generation, that will not be basically charged at a lower level. So balance, whatever you're taking from the grid, that only will be charged at higher tariff. So that's why somewhere it is beneficial for the project other than the net metering. Now, one more concept have come for the virtual net metering. So what is basically virtual net metering? That if you have one campus and you have one metering system, you have put lot of solar or renewable energy in the campus. And now virtual net metering talks that all the solar energy all the renewable energy can be accounted for one building. So it should be come through proper documentation, and some agreements is required. So entire energy generated from RE system is exported to the grid from renewable energy meter or gross meter. And the energy exported is adjusted in either one or more than one participating residential consumers, including common connection of housing society located within the same distribution license area or supply. If you see, before, all the three concept talks about the one-to-one project basis. Like if you are installing a solar on one building and having a separate meter, then you can't take this for the other building. But here, if you see in virtual net metering, if a campus has multiple buildings and you have put solar everywhere, and that can be basically going through one gross metering at a campus level, but all the solar can be accounted for one building. So this is also have come up in the discussion. So I thought I'll basically give you idea. Right now, it is not implemented anywhere, but discussions are going on virtual net metering also. So these all slides, what I have presented is talk about on-site renewable energy and what are the measures available to have the on-site solar or renewable energy, install later project. Now I am talking about the offsite renewable energy. After having on-site renewable energy, still some projects are finding challenge to meet their whole requirement through solar. Because if you see big commercial building, IT buildings, so they have a limited rooftop area. That is not enough to generate energy for their whole consumption. So what they are right now doing, they are taking the renewable energy from offsite projects or offsite renewable energy projects. So how it can be done? If you have heard about solar park or solar wind hybrid parks, so they are located at some remote location or out of the, I can say, boundary of the project, and they are generating renewable energy. But through the discom, they come in agreement for a long term, like 7 years, 10 years, 15 years, or 20 years. They will, whatever the generation coming from this renewable energy source, it will be accounted for the consumption of that particular project or building. So that means generation is happening somewhere else, but through the documentation, proper involvement of all the three party, like one project, one who generates the solar energy or wind energy, and third is the discom. That whatever the energy coming through this solar park is only accounted for the project. So that means after having on-site capacity, whatever is the balance energy available, energy consumption is there, that can be offset through the offsite renewable energy. It comes with, see, I told about the agreement, because it is not a constant energy, because the renewable energy depends on several factors. The one, if you talk about solar, it is based on the daytime. There is a good generation. Even in daytime, they vary. In different weathers, the generation varies. So that's why it comes with the minimum or maximum energy supply guarantee. You can't guarantee that it will come certainly so much of amount. That's why in the PPA, they come up with a range that minimum you will get so much energy and maximum will be given that much. Because to cater this challenge of variation in the generation. And certain charges to be paid to discom for their transmission, wheeling, and banking charges. So what is happening? We are using the infrastructure of the transmission network of the discom. So that's why we have to pay certainly charges to the discom. Other option is right now, after having this open access PPAs, government also have certain obligation to buy renewable energy in their energy distribution. So what is happening? Government is buying renewable energy. They are supplying anyway to the projects, but it is not recognized. So government has come with the green energy and the green tariff, that if any project wish to basically take the certificate from the government body that whatever the energy they are taking from them is a green energy, the government is providing that. And by how can they provide? They are basically charging some additional premium amount on the regular tariff. Like if right now energy tariff is 8 rupees, then it will be 8.6 or 8.7 rupees per unit. Then government will give the certificate that whatever energy you are consuming, it is a green energy. So if you don't have access of this open access PPAs, then you can adopt this green energy and the green tariff to showcase that whatever consumption you have, it is coming through the renewable energy. Even third option is the renewable energy purchase or RECs, which is regulated by CERC through approved energy exchange platform. It is again one concept. Someone who wants to know more about this, we can discuss separately, because it's a very technical thing. So after having all this discussion on renewable energy, as I told earlier, that we have a net zero energy rating system, net zero carbon rating system. So how this renewable energy basically helping to achieve this net zero status for their project? So under the net zero energy rating system, we talks about two things: energy efficiency and renewable energy. And if you see, we have given more weightage on the energy efficiency, because we want project to reduce first their energy demand, and after that, whatever the demand, it should meet through the renewable energy. So these are the mandatory requirements. First, energy efficiency should be there. How energy efficient should be there? That for the commercial building, IGBC criteria is already there. Energy efficiency basically codes come from the BE. As per the BE, there are certain parameters or certain benchmarks are given for the different buildings. So that should be met under the mandatory requirement of energy efficiency. Second mandatory requirement, that you should have energy, this renewable energy. And third, without compromising the thermal comfort, indoor temperature, RH, fresh air, project should meet this criteria. Otherwise, it should not be like I'll switch off all the things and now whatever the consumption, I have reduced the consumption a lot, and now I'm become net zero. So it's not the mean. You have to run your operations without compromising indoor thermal comfort and temperature and RH. And after having this all, whatever the consumption you have, it should meet through the RE. So as I told, these are the pictures, some of the pictures from the different project where they are utilizing all the space available for installation of on-site, and balance to be catered through off-site renewable energy. So these are the 3 rating levels we have. One is near net zero, where 75% of the building requirement should come through RE sources. Second is the 100% of the renewable energy should come through the RE. And net zero platinum, it's not only about the meeting the renewable energy, it's also talk about if you're achieving 80 credit points. That means out of 75, if you're achieving highest 70 plus and then balance 80, 11 or 12 from the RE, then you can achieve this net zero energy platinum. That means focus is more here on the energy efficiency. This is the project where, as I told in initial first slide, that we have achieved net zero energy platinum rating because we have done lot of retrofits to reduce our demand first. And then we have put 138 kilowatt of the solar system. It is a bifacial solar module. And right now we are not only net zero energy platinum in terms of the meeting our requirement through renewable energy and having energy efficiency, we are exporting because we are generating more than what we require. This is the second project. It is under in the Capgemini. It is in Pune. What they did, they have installed 2 megawatt of on-site solar power plant. After having 2 megawatt of solar power plant, still they are not able to meet their renewable energy requirement by 10%. So what they did, they are basically offsetting through green energy under green tariff. What I told earlier, what I discussed earlier. So right now they are almost 78 lakhs of units annually offset through RE, and they are good in energy efficiency. Their EPI ratio is more than it's almost 0.69. So in carbon, also in net zero carbon rating, if you see which are projects in operation phase, there is first you have to implement all the ratings like energy, water, waste, because it is an integrated approach. And second, after having all this, whatever the energy consumption you have, it should meet through the RE. So in carbon rating system also, we have 2 near net zero carbon and net zero carbon, which talks about if you are able to offset 75% of your annual operational carbon, then you will become near net zero. And you are able to offset more than 90% of your annual operation carbon, then you will become net zero carbon. So see, how can you offset this operational carbon? Through renewable energy only. So that's why if you see, highest point is given under the offset operation carbon, that is 30, and that can be done only through RE. So that's why we are more focusing on RE, because it is required to offset your operational carbon or your offset the energy consumption, because this is right now only the way. Carbon sequestration measures are still in discussion. Some technology are already developing in the laboratories, but it is not commercial viable. So that's why right now only option available is the RE. So these are the different projects right now which are working with us for their meeting goal under the net zero. You see all the big developers, all the big companies, all the government sector big companies are with us for their meeting and meeting their net zero the goals, and we are supporting them to achieve net zero status. Thank you. So if anyone has any question.
Thank you, Naveen, for the session. I think we have a couple of questions in the chat box.
Just a minute. Okay. Please. I can see one question. What is the carbon sequestration? Carbon sequestration is basically, see, there are operational carbon emissions because of your building operations, like you are using many sources which emits carbon. So how you can basically offset this carbon emission? There are certain technologies by which you can capture that carbon. Like have you heard about, see, even these trees which we plant, that also basically consume carbon dioxide for their reproduction or basically generating the oxygen. So that is also where we can consider about the carbon sequestration. Even you heard about the carbon is basically taking into the deep sea for the sequestration, like capturing the carbon. That is basically mean of the carbon sequestration. There are a lot of discussion on scope 3, GHG. See, basically this discussion is majorly on the renewable energy thing. So if any discussion for the GHG, scope 3 and other thing, we will take it separately. Otherwise, it will be basically not in line with the theme of this webinar. Okay, green tariff policy. So right now what is happening, government has come up with this policy that if any project or any building who is consuming energy from them wants to recognize that energy as green energy, then government can recognize that green energy, that energy into the green energy by charging some premium amount. As I told, right now if 8 rupees is the tariff. So if you want that energy to be recognized as a green energy, then government is charging 77 paisa or 66 paisa based on the different discom to recognize as the green energy. Because see, what is happening, discoms are also getting different energy sources, energy from different sources, like they are also getting from thermal, hydro, renewable, because they have obligation to buy. So now they have already energy mix. Now if some project from this energy mix want to recognize that whatever the energy they are consuming as a green energy, then government says I'll charge something, and later after completion of the month I can recognize your energy as a green energy. So that is the basically green energy under green tariff. So there are a lot of questions. So if someone can help me, which should I take and which should I answer?
So there's a question on this solar panels causing carbon emissions. Maybe you can
See,
address that.
right now what is happening, solar panel manufacturing definitely emitting carbon emissions. There is no doubt in this. But what is happening after manufacturing, whatever the solar panels are there, that they are not basically emitting any carbon emission. Yes, in manufacturing process, you take anything, definitely carbon emission will be there. But after having complete manufacturing process, there is no carbon emission. So after having installed the solar, whatever the energy you're getting, it is a clean energy. There is no carbon emission related to that. Next question, it's very tough. If anyone can help me, because a lot of pop-ups are coming with different questions.
So there's one more question. Is net zero applicable for manufacturing industries or factories?
Yes, our one of the sister council, Green Co, is there, which certifies factories, industries under the net zero. So factories, manufacturing industries can be taken under the net zero certification. But yes, IGBC is not taking any factory building under the factory, not building, factory for the net zero assessments. What is the lifetime of solar panel? See, right now, lifetime, if you term in lifetime, there are two things. One is the technology lifetime, one is the lifetime of the operations. Solar panel can work more than 30-35 years. But yes, technology changes a lot. So now, if you see, the government is telling 25 years should be the technology lifetime. Like after 20-23 years also, that same panel, if this any issue comes, it should be replaceable under the warranty. So lifetime, it is more than 30 years, because I have seen panels which are manufactured in 82 are still working. So lifetime is not an issue. Yes, generation depletes because of the various efficiency losses. But if you talk about the energy lifetime of the technology, it is varies. Like if you tell me, I am working since last 2011, I have seen a lot of technology changes. Whatever manufactured in 2011 right now is not available in the market. No one is manufacturing that capacity. It was at that time 200 is the biggest size. Now 600 plus watt capacity of single modules are available. So that's where technology is very, there is no life for technology. Yes, solar panel can work more than 30-35 years. There is no, yes, generation will be low, but they can work. Power, I'm not able to get the question. Any question you think I should answer?
I think the
Solar
question.
efficiency. Okay, right now 20 to 23% of solar cell efficiency are there. Even solar cell, if you talk, it is more than 24%. But when it comes under the module, it is 20 to 23%. For the normal, I'll talk about this mono PERC. There is one technology of cells. They are having 20 to 23% of the efficiency. Because solar cells have higher efficiency. Like if solar cell has 24, 25, then when it comes in the module combination, it reduces its efficiency by 1 or 2%, then it becomes 20 to 23%. Anything other than this? Yes, BIPV also made in India. Many manufacturers are coming with this BIPV. Oh no, sorry, BIPV, that building integrated PV. So see, some companies have started this BIPV, but it is not that commercial viable, because right now we have enough roof area, we have enough. See, BIPV has some challenges. They will not have that much of BIPV cells and regular cells. So in BIPV also there are different type of cells. Have you heard about inorganic cells? Some CDSE, CDGI. There are a lot of types of cells. So right now in normal modules we are getting crystalline silicon cells. BIPV can also basically can be have this crystalline silicon, but yes, definitely these are more flexible. So different type of cells also can are used in this. So maximum capacity basically depends on the area available. If you have huge area, you can go more than 2 megawatt, 3 megawatt. But if you consider the net metering or within net metering or not net metering, it's based on the policy available. Like in Rajasthan, it has declared that up to 1 megawatt only consider under the rooftop solar power plant. If you have more than 1 megawatt, then it cannot taken under the net metering. It cannot be considered the rooftop. But in Maharashtra, it has increased up to 5 megawatt. So it's based on the different government or different state policies. Any other questions?
I think we are done with the questions, Naveen. Sir, would you like to add something?
Yes, open access is available in major states, but yes, certain states are not encouraging open access because of their commitment with the different thermal or the I can say conventional energy power plants. So open access is mostly in states are available, but again, it is not. You cannot go for a smaller capacity. There are certain economics involved in this. So generally, as per the government, 100 kilowatt is kept as a minimum capacity for the open access agreements. But if you see commercially, generally projects are coming with 1.5 megawatt and 2 megawatt of the connection sanction load. If you have, then only they are coming with the open access agreements. Below that, right now, no one has basically agreed, or no one generally agrees.
Shailesh, sir, do you want to add something so we can close this?
No, there's a one question like BIPV cells and regular solar panels are similar. Regular solar panels we keep aligned to the as per solar path, but BIPV is generally not on roof, they are in on the building surface. And another difference is when we have a regular solar, if it is not bifacial, then one side is glass and another side is a plastic thing which doesn't allow light to go through. But in BIPV, whatever I understand, it allows a lot of light to go through. So wherever you want some kind of a rain protection or this thing facade, you use it, it allow light to go in and as well as give you the energy production. So this kind of a thing I think. And apart from solar, wind, there are thousands of things which we can do to make our building net zero. Net zero for energy. So production is one thing and saving is another. So building design, by using a lot of passive design elements, we can do lot many things. So it is not only these two, but I'm sure we will have some other seminar where we will talk about those interventions also, where without generation or without this thing, we can save a lot of energy and which will contribute to our building to a net zero building.
Yes, sir. Regarding the same thing, we have continuous seminars lined up for the next 3 days on different topics related to the net zero theme. So I would request all the participants to participate in the next couple of sessions which we have lined up for you. And I can see one question, poster competition, so which was said by Mr. Himanshu. So there is a nationwide poster competition which IGBC is running, and the last date is 12th September. If you can go to IGBC LinkedIn page, you can find the post regarding the poster competition. So you can upload your poster design over there, and we will be awarding the winner. So thank you, Shailesh sir. Thank you for being here with us. Navin, thank you for your presentation and thank you for addressing all the concerns and everything.
Thank you everyone. I hope the information provided by me is helpful for your understanding for renewable energy. If you have any further question or queries, you can ask, or you have our email IDs, and we will respond that. Because it is a wide subject, it can't be covered in 15-30 minutes. But yes, I tried to touch all the aspects. Definitely, these are all practical aspects. Definitely, there will be a question. So you can post your questions and we will respond on that.
Thank you very much.
Thank you, everyone. Thank you.
Thank you. Thank you.